are almost done of December. We are, what is today? December what? 13th? 14th? Which means you only have 9 days until Christmas break, right? And only 11 days until Santa Claus comes, right? Are we? Oh, well. Better get going then. Question number one is true, false. Actually, the first four questions are true and false. And it says, does this power equal this power? So are they the same thing? No, but are they equal in value? Well, we can see if we solve it using our simplification of a power. So negative 2 in brackets, meaning it's the base, to the exponent of 4 means you take the base, negative 2, and multiply by itself 4 times. And when we work this out with BEDMAS, a negative base to an even exponent always gives us a positive product. And the simplification would be a positive 16. In the second question, we have negative 4 around the brackets, meaning it's the base squared, which means we take the base and multiply it by itself this many times, giving us 16. So therefore, is it a true statement, but both powers have the same thing? Yes, it is. It's true, 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 and that's the reason. Our next question asks us, is negative 5 in brackets to the exponent of 0 equal to 1? The answer is yes, true, it is. Why? Because any base to an exponent of 0 is 1. Now, there is kind of an exception, and if the question on your test was this, would you say true or false for that one? False. Because what's the base? The base is not negative 5. If it was negative 5, there would be brackets around it. Because there's no brackets, we need to interpret this as being the opposite of 5 to the exponent of 0. So therefore, this would be this, right? Not 1. So you got to be careful. If you're talking about any base, if it's a base, if it's negative and it's a base, it has to be in brackets. If it's not in brackets, it will always be a negative standard form. Question 3. Now, interesting question. Is the base in brackets or is the power in brackets? The power is in brackets, which means it does not follow that negative base rule. This here is the same thing as this here. Some people say, well, why are the brackets around it? Well, we might have like a negative 2 multiplication out there. We want to separate this negative sign from the rest of the expression, making sure that it's not interpreted as a subtraction question instead of a thing. So sometimes we use brackets that way. So this is actually equal to the opposite of 5 squared. So it's actually equal to negative 25. And therefore, our answer for this one is true. They do have the same value. So you just got to remember that this here is true, but this here is not true. They're not equal. Does that make sense to everybody? Okay. Our next question is an exponent to an exponent, which is really law 3. If we think about this, the power has brackets around it, which means we can consider it our base to an exponent of 4, which means the base, which is this, multiplied by itself 4 times. And I can use that little dot there, by the way, to represent multiplication. And we know that if we're multiplying 4 powers that have the same base, the law 1 says you can keep the base and add your exponents, which would give us a standard form of 2 to the power of 16. However, way back in grade 4, you learned that repeated addition can be expressed as multiplication. So if we apply law 3, a power raised to a power, you can simply keep the base and multiply the exponents because these are the same thing. And you still get the answer 2 to the 16. So either track, you got the same answer. This proof works. This proof is better because it shows that you understand the law that's being applied. Any questions with the 4 true and false? We are good. I think, is that what it was? True, 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 false? Is that right? Is that right? Okay. The next question, 5, says arrange these in descending order. You're given 5 powers. When you're doing this, just take each and write them in standard form. Any base to an exponent of 1 is itself, but this one is the opposite of 4 to the 1, so negative 4 is the answer. A negative base in brackets to an odd exponent, we know it's going to be negative. It's negative 32. Any base to an exponent of 0 is equal to 1. Is the base negative 24 in this one? No. If it was negative 24, it would be in brackets. So this actually says it's the opposite of 24 to the 0. Since 24 to the 0 is 1, this would be equal to a negative 1. If anyone made a mistake, it's probably here. And finally, 1 to the power of 26. 1 multiplied by itself any number of times is 1. So then it says in descending order, which means you start with the largest. So our first one is this. I would do this on my test if I were you, but make sure you don't scribble it out to the point where I can't read it anymore. Our next largest is this. Done. Our next largest is this one. Our next largest is this. And finally, our last largest is negative 2 in brackets to the exponent of 5. Ascending order. Question 6 says, write as a power, or write in exponential form. 5 multiplied by itself 4 times, very simply, is 5 to the exponent of 4. Negative 10 in brackets, written multiplied by itself 3 times, is negative 10 in brackets, because that's the base, to the exponent of 10. Can anyone tell me, just out of curiosity, just real quick, what would that have been in repeated multiplication if I asked that? Who knows the answer to that? Ben, what would you have written? No, what would you write as a repeated multiplication if that's the question? Negative 10 times 10 times 10? Not wrong, but not right. Daniel, what would you have done? Good, you could do it either one. I'm going to do it both ways. We know that if you took any number, let's just take 5. If you took 5 and you multiplied it by negative 1, what would you get? It's opposite, right? So you could write it like that. A better way to write it is just the opposite of 10 times 10 times 10. Both of these ways express the same thing. If you're going to say the opposite of 10 cubed, you need to have this right here as a part of it, or this as a part of it, and then just your 10 cubed, right? That's how you would write it in exponential form. Question 7, write in repeated multiplication. So 6 cubed is 6 times 6 times 6. Negative 5 to the 5 is negative 5 times negative 5 times negative 5 times negative 5 times negative 5. Notice here I didn't use dots because I can. Notice here I didn't use dots or multiplication symbols because brackets next to brackets imply multiplication. 10 to the 1 is just 10. And negative 2 squared, like we just said, Daniel just did just a second ago. It's the opposite of 2 times 2, right? So if anyone made a mistake, it's probably with D, I would suspect. Make a note of it just to make sure. Question 8, rewrite the expression in parentheses. Wow, what a good use of the word parentheses. Who knew there was 2 T's? Who knew? I didn't know. Actually, I probably spelled it wrong now that I look at it. As a single power, and then write the entire expression as a single power. So write each of these in parentheses. So 6 squared multiplied, what's that? 6 to the 4. Oh, yeah. Yeah, I must, expression. It's not even a word. All the single powers, all the single powers. I put your hands up. What do you do when you multiply 2 powers that have the same base and different exponents? Piece of cake. You keep the base and you add the exponents, meaning as a single power, your answer would be 6 to the 6. And the next question, you would have 2 squared multiplied by 2 to the 6 divided by 2 to the 3. And it's okay to write it like 2 squared times 2 to the 6 over 2 to the 3. That's fine too, totally legit. Or you could actually write 2 squared in brackets multiplied by 2 to the 6 divided by 2 to the 3. That's totally legit as well. All three of those are the same, just written differently. If you have it, you're going to simplify the numerator, which is going to be keep the base, add the exponents to give you 2 to the 8. Divided by 2 cubed. And now that we're using division of same bases, keep the base, subtract the exponents, your final answer as a single power is that. Question 9. Write each expression as operations of 2 powers. If it can't be done, write Can't be done, or CBD. So really what I'm asking you is, given these four, do you understand what Rule 5 and Law, or Law 5, Law 6 says? Law 5 and Law 6, when you have the product of two numbers in brackets to an exponent, you can equally distribute those exponents to this, and you would get this. With addition, we explicitly said this law does not work, and therefore you can't do it. So therefore you can't simplify that using this. Division you can, meaning you can get 10 to the fourth divided by 3 to the fourth. And this one, because of subtraction, you can't, so you just can't do it. Okay? Are we all good with those two? That's just making sure you understand that you can't use the distribution of exponents with addition and subtraction, but you can with division and multiplication. Stop me if you have a question. Vocabulary, the number in a power that is multiplied repeatedly. The number, that's your vocabulary, is called your base. Right? The number in a power. So for example, if it was 2 cubed, it would be this number that's multiplied by itself this many times. Question 11, the number in a power that indicates how many times to repeat itself. That's that little bad boy there. It told me 3 times, and that is called B, an exponent. An expression made up of a base and an exponent is called, wait for it, a power. I've found the power. It's getting kind of, I got all kinds of 80s songs going today. Question 13, a form for writing a number so that it's made up of a base and an exponent is exponential form. And finally, a number that multiplies a power is your coefficient e. Remember, if I had 2 multiplied by 3 squared, that 2 was called your coefficient. If I had in algebra 2x squared, almost the exact same expressions, except this time in the first one, I defined the base as 3. In the second one, I defined the base as x. Both are the same thing, but 2 is your coefficient, x is your variable, 2 is your exponent. Question 15, BEDMAS order of operations with exponential form. The first one says 10 squared minus 2. So we have actually, if I was put my operations here, I'd have an exponent, I'd have a subtraction, I'd have an exponent, I'd have an addition, and I have an exponent. I have five, what do you call those? Operations. In BEDMAS, we're going to solve our brackets, our exponents, our division, multiplication, our addition, subtraction, 1, 2, 3, 4 steps. Is this a bracket right here? Are those brackets for do this first? No, because what's inside there is just the number -2. There is nothing to simplify within those brackets, and therefore, that's not actually a B. That's just a straight up separation of a negative sign from a subtraction sign. That's why the brackets are there. So, or defining the base as well. So we're going to simplify our powers. 10 squared is 100. -2 cubed is -8. Notice how the subtraction is still a subtraction. And the -2 cubed is -8. You have to use brackets. Plus -5 squared is a positive 25. I don't need brackets there, but I like them. Now we just have subtraction and addition. Subtraction I don't like doing, so I always like to keep flip change to get 108. And 108 plus 25 is 133. Your final answer. In your next question, you have a power to an exponent. You could just say, what's 2 cubed times 2 cubed times 2, or 2 cubed times 2 cubed times 2 cubed. Or you just know that it's going to be 2 to the exponent of 9 plus 5 to the exponent of 1 minus 1 to the exponent of 100. That's fine. You can just simplify it like that first. Then you could just do your multiplications of 2, 2, 4, 8, 16, 32, 64, 128, 256, 512. And if you didn't know that, you just grabbed your scientific calculator for your test, because of course you know you need to have a scientific calculator if you want to be able to do these, not your phone. And you get 512. Plus 5 to the 1 is just 5, and minus 1 to anything is just 1. Now that you have that, you get 517 minus 1, which is 516. All right, any questions on 15? We're good? Yeah, it's good. More BEDMAS. 2 take away 3. So we got brackets here. We finally have B. We have an exponent, that's step. We got an addition, we got a multiplication, we got an exponent, we got a division, we got an exponent. We actually have a whole bunch of operations here. So we'll solve our brackets first. 2 take away 4 is -2. Keep it in brackets because it's still my base. Just solve the brackets first. Now we'll do all my exponents. Negative 2 cubed is negative 8. Negative 3 squared is positive 9. Negative 2 to the 1 is just negative 2. So once I solved all of my exponents, I now have this. You do have a multiplication, and yes, this is division, but you still have to simplify your whole numerator first. So I'll just extend this way. And some people say, even though there's division there, that's not done until you simplify the numerator, which would give you 46. Positive 46 over negative 2, which gives you a final answer of negative 23. Is that right? Did everyone get that one? Did I make a mistake? Good? Okay. And your last question gives you negative 1 to the 4th minus negative 1 to the 4th plus 1 to the 5. Brackets, so it's negative 1 times negative 1 times negative 1 times negative 1, which is positive 1. Take away. Will this one in here be positive or negative? Negative, because it is not negative 1 to the 4th, because the power is in brackets, not the base. And therefore, it's the opposite of 1 to the 4th. 1 to the 4th is 1, the opposite of which is negative 1. So look, subtraction sign is still a subtraction sign. The simplification of the power is a negative 1, plus 1 to the 5 is just 1. Keep flip change, boom, 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 that's 2. 1 plus 1 plus 1 is 3. How many had 1 for an answer? I bet you a lot of you. Nobody that's going to tell the truth, I see. Okay. A genie appears and said, I will give you 1 cent, and every day for 2 weeks I will appear and quadruple it. Or I will give you $2 million. Which is the better deal? Well, to the untrained eye, to the one trained eye, that 1 cent a day seems like a pretty big ripoff, doesn't it? It seems like it. You're only going to get 4 cents on day 2. Doesn't seem good deal to me. I'm taking the 2 million. I'm walking away. Your formula is SRT, or S multiplied by R to the exponent of T. Okay, if you want to think of it differently. And what this means is S represents your starting number. R represents the rate of change. The rate of change in this case will be doubling, tripling, quadrupling. So if it's doubling, you're going to be, the rate of change is 2. If it's tripling, it's 3. If it's quadrupling, it's 4, etc. And your T is the number of appropriate time units. Number of appropriate time units. That's what our formula kind of means for exponential growth here. Simple exponential growth. So if we take our formula and we substitute S is 0.01, that's how much money I start with. The rate of change is to quadruple, which means our number in brackets will be 4. And the number of time units, it's for 2 weeks. Every day for 2 weeks. So how many days are there? There are 14 days. So when we plug in the information, that's our substitution. Knowing BEDMAS, I got to do my exponents first. So 4 to the exponent of 14 doesn't seem like it's going to be that big a number. Oh my God, it's 268,435,456. 268. 435. I don't remember the number. Who am I kidding? 456. Wow, that's a big number. Multiplied by 0.01. Now, there might be some people that automatically jump on grab the calculator and figure this out. But do you remember, if you multiply something by 100th, what do you actually do to the number in question? The opposite of what you would do if you multiplied by 100. You all know if you multiply by 100, you move the 2 decimal places that way, right? When you multiply by 100th, you move the decimal 2 places this way, meaning your answer would be 2,684,354,056. You know, really, at the end of the day, if I had have actually gone with the $2 million, I'm not going to be heartbroken. I only lost $684,000, which I'm still rich. I'm still a millionaire. So thank you, Mr. Genie. Either way, I was happy. And your last question looks incredibly complicated, but it's not bad. It's just, can you work with a formula? If you take sciences in high school, you will deal with formulas that are fairly complex looking. This one is the estimation for the stopping distance of a car on an ice and road. It's an actual formula. It's a real thing. The distance, D, is measured in meters. So D equals stopping distance. And I'm going to put meters here. S equals, I read here, S is the speed of the car in kilometers, but so it's speed in kilometers per hour. And your the C is the mass of the car. So C equals mass of car. And that's in kilograms. Now, it might seem silly to rewrite it this way because you have all the information in here. But I will tell you from experience, rewriting it in a nice little key makes a lot of difference when trying to reconstitute your answer afterwards. So take the time to write this. You won't regret it. Once you have that, you then says, what is the stopping distance for my 1,500 kilogram Volkswagen Beetle if my car is traveling at 75 kilometers an hour? So because there's three, if I write this formula again, 0.75 S multiplied by C divided by 1,000 squared. In this formula, you should know two numbers and you don't know the other. So in all sciences, you're always going to want to find it by substituting the ones you don't know. So I know that stopping distance for my car. I know my car weighs this much, which is right here. So my C is going to be 1,500. I'm going to put that right there. And traveling at 75, that's my speed, 75. So I kind of made a note there. So I'm not going to screw this up. I don't know my D. So D stays D. That's what I'm going to solve for. 0.75 multiplied by the speed, which is 75 again, multiplied by the mass is 1,500. So C is replaced with 1,500 divided by 1,000 squared. Okay, everything's in there. It's not so bad anymore because I have a multiplication, I have a division, and I have an exponent. Of those four operations, which one am I going to do first? Say again? Brackets, because there's something in there, isn't it? So really, this division is going to be the first thing I do because it's in brackets. So 0.75 times 75 times, what's 1,500 divided by 1,000? 1.5 squared. Now I have a multiplication, and I have an exponent. Do my exponent first. 0.75 times 75 times 1.5 squared is 2.25. Now I just have a string of multiplications left. Grab my calculator. 0.75 times 75 times 2.25 equals 1265625. 1265625. Well, here's an interesting one. What does that mean? What did I solve? What did I do all that work for? I got to go back and think, well, this is what I solved, and I have this answer D equals 126.5625. So then I go back up. What does D mean? It means my stopping distance in meters. So therefore, watch this, therefore symbol. If my 1,500, if my Volkswagen, I won't even put that, I'll just put if my car is traveling 75 kilometers per hour, it will take 126.5625 meters to stop on an icy road. Does that make sense to everybody? So if you're driving at 75 kilometers an hour on icy roads, a 1,500 kilogram car, by the time you put on the brakes, it's going to take 126.5625 meters to come to a complete stop. That's why slow down on icy roads.